Okay, guys, let's look at mole concept number 5, which is converting between the number of moles and the mass of a compound. The one thing that I want you to remember for all of these is that you have to convert, or I should say calculate the molar mass of each compound. So let's do that first. Let's look at example number 1. Calculate the mass of 2.5 moles of C3H52S. So we're going to do just like we did in concept number 4, where we had to calculate the molar mass of compounds. So let's calculate the molar mass of C3H52S. So start by looking at what elements are in the compound. So we have a C, we have carbon, hydrogen, and sulfur. So we're going to need our periodic table so we can use all of these values, all of our atomic masses. Next, we need to figure out how many of each carbon, hydrogen, and sulfur we have in our formula. So for carbon, we're going to look, we have 3 carbons in our formula times the 2 from outside the parentheses, so that's going to make a total of 6 carbons times 12.01, and that's going to give us a mass of 72.06 grams. Now let's look at hydrogen. Again, we're going to have to take the 5 H's from inside the parentheses multiplied by the 2, so that's going to give us a total of 10 times 10 hydrogens times 1.00797 grams, which is going to give us an amount of 10.08 grams of hydrogen. Then we have 1 sulfur times 32.06 grams, and that is going to give us 32.06 grams of sulfur. Remember, this is not the molar mass of the compound. This is the mass of the individual atoms that make up that compound. So we have to add these together. So our molar mass for our compound is going to be 72.06 grams plus 10.08 grams plus 32.06 grams. And that's going to equal an atomic mass, or I should say a molar mass, of 114.2 grams per mole. Now we're going to use this 114.2 grams per mole in our actual problem. Remember, what we have just done, calculating the molar mass, is preliminary work that we're going to need to do, and we're going to use this number to calculate the actual mass of 2.5 moles of C3H52S. So let's start off with what we're given, that 2.50 moles of C3H52S. We are going to multiply that by our conversion factor. Since we have moles at the top, we need to put moles on the bottom. So remember, here's where our molar mass is going to come into play. Our molar mass says that we have 114.2 grams of C3H52S in 1 mole. So that 114.2 grams needs to go in the numerator so that the moles can cancel. When you type that into your calculator, you will get an answer of 285.5, and the unit, remember when we do problems like this, you look for the unit that is uncrossed off on top, and that will be grams of C3H52S. Let's look at example problem 2 now. Example problem 2 is a little bit different. So we're going to calculate the number of moles in this case in 325 grams of calcium hydroxide. So again, we will need the molar mass of this compound. So we need to calculate the molar mass of calcium hydroxide. So let's start off by listing all the elements that are in calcium hydroxide. We have Ca, we have O, we have H, and we also need to get our atomic mass values from our periodic table. So now what we're going to do is we're going to figure out the molar mass of calcium hydroxide. So in this formula, we have 1 Ca with a mass of 40.08 grams, and that will give us a mass of calcium of 40.08 grams. We have 2 oxygens in this case because the 2 from outside the parentheses has to be multiplied in. So we have 2 oxygens times the mass of each oxygen, which is 16 grams, and that'll give us a mass of 32 grams for oxygen. For hydrogen, again, we have to multiply that 2 into the parentheses, so we're going to have 2 H's times the mass of hydrogen, which is 1.00797 grams, and that'll give us a mass of 2.016 grams. Now, since we have not figured out the molar mass, we've just only figured out the mass of each individual compound, we need to add these values together. So 40.08 grams plus 32.0 grams plus 2.016 grams is going to give us a molar mass of the compound of 74.096 grams per mole. Remember, molar masses are grams per mole. So we've done the preliminary work. Let's solve our actual problem. So let's start off with what we're given. We're given 325 grams of calcium hydroxide, and we're going to multiply that by some conversion factor. So we need our division bar. Now, since we have grams of calcium hydroxide on the top, we're going to need to put grams of calcium hydroxide on the bottom. And that is where we're going to use our 74.096 grams that we've just calculated, and then 1 mole of calcium hydroxide on the top. Since the grams of calcium hydroxide cancel out, we are left with the unit that we are looking for, which is moles of calcium hydroxide. So that's going to be then equal to 4.379. And again, what's our unit? Our unit is whatever is in the numerator uncrossed off, and that's going to be moles of calcium hydroxide. Now go to your packet, and I want you to complete the rest of your practice problems.